In 1959, a 38.8-liter V12 engine producing 525 horsepower rolled out of Minsk, built to haul 50 tons across roadless Siberia. The MAZ-537 became one of the largest military vehicles ever engineered, and it existed because every fixed Soviet missile site could now be found and destroyed. Subscribe and follow this investigation. The road-going giants Moscow, built to solve that vulnerability, would quietly reshape the entire logic of nuclear deterrence. In 1959, a new kind of machine rolled out of Minsk, the MAZ-537. Soviet leaders needed a way to keep their nuclear forces safe from enemy eyes. Fixed silos were too easy to spot and target. The answer was mobility, on a scale the world had not seen. The MAZ-537's 38.8-liter V12 diesel engine, the D-12A, produced 525 horsepower and 2,200 newton-meters of torque, enough to move more than 50 tons through snow, mud, and across rivers where roads did not exist. This was not a civilian truck engine. It was built for armored vehicles and ships, then adapted for a new mission, moving the heaviest loads anywhere, anytime. The 8-wheel drive system sent power to every axle, using a hydromechanical gearbox and planetary transfer case to keep all wheels turning, even in the worst conditions. Suspension-paired independent torsion bars up front with leaf springs at the rear, keeping the tires grounded. A central tire inflation system let drivers adjust pressure from the cab, spreading the weight and keeping ground pressure low enough to cross deep snow without sinking. In the Arctic, crews started engines at -45 degrees Celsius, using electric oil sump heaters and glycol preheaters to keep the diesel flowing. Chief designer V. Kuznetsov put it simply, "We had to build a tractor that could move a missile or a tank anywhere in any season without roads. The enemy could see everything from above. Our only defense was to keep moving." The MAZ-537 did not just haul cargo, it made mobility a weapon, setting the standard for a new generation of military vehicles. August 1967 saw the first Kraz 255 roll out of the Kremenchuk plant. At first glance, it looked like a brute, a 6x6 truck with a cab set high above massive, low-pressure tires. But underneath, it was the backbone of Soviet field logistics. The 14.9-liter YAM Z238 V8 engine put down 265 horsepower and enough torque to pull artillery, bridge sections, or fuel trailers through mud and deep snow, where roads disappeared and maps became guesses. Over 12,000 units were built by 1993, a scale that dwarfed any Western equivalent. In the field, the Kraz 255 was more than just a hauler. Artillery regiments depended on it to tow 130mm M46 guns and BM-21 Grad rocket launchers into positions that would have stopped lighter trucks cold. Engineering battalions used it to lay pontoon bridges, move earth-moving equipment, and ferry supplies across the Siberian taiga. Its low ground pressure, thanks to those wide, balloon-like tires, meant it could cross marshes or snowfields without bogging down. A vital trait for resupply runs to Arctic outposts or during spring floods. Life with the Kraz 255 was about improvisation. Veteran crew chiefs tell of field repairs done with little more than wrenches, wire, and spare hoses. The truck's design made this possible. Side panels on the portal axles could be unbolted for a quick gearbox swap, and the hydraulic winch up front let crews pull themselves or each other out of trouble. In the Far East, a mobile workshop based on the Kraz 255 could replace a blown axle in a snowstorm, then get back to hauling within hours. The Kraz 255's reputation was built not just on size or power, but on the culture it created. Crews learned to trust that with enough determination and the right tools, their truck would get through, no matter the terrain or the mission at hand. Soviet mobility, in practice, was less about dazzling engineering and more about relentless, adaptable service. The Krejcie's 255 was proof that in the Cold War, the unsung workhorses mattered just as much as the headline-grabbing giants. A Soviet engineer once described the heart of these machines as a system of nerves and muscles, not just metal and fuel. At the core is the drivetrain, a network of shafts, gears, and differentials that splits engine power to every axle. On a 6x6 or 8x8, each driven wheel gets a share of the torque. So if one loses grip in mud or snow, the others keep the vehicle moving. Torque isn't just raw force, it's about how that force is delivered. A planetary gearbox with a torque converter, like the one in the MA's 537, smooths out the power so a 50-ton load can start rolling on soft ground without snapping axles or stalling the engine. Suspension systems are more than springs and shock absorbers. In these vehicles, hydraulic or air leveling keeps the chassis balanced even as cargo shifts or the ground drops away. This means each axle carries its share, reducing the chance of tire blowouts or broken frames. Articulation, the ability of each wheel to move independently, lets the truck crawl over ditches, rocks, or frozen riverbanks without losing contact with the ground. Centralized tire inflation systems let drivers adjust tire pressure from the cab, matching the terrain in real time. Lower pressure spreads the weight, reducing ground pressure and preventing the truck from sinking into snow or marsh. On hard roads, higher pressure cuts rolling resistance and saves fuel. In the Arctic, cold start technology is essential. Electric oil sump heaters, glycol preheaters, and battery blankets keep the engines ready to fire even at -50. Every system, from the gearbox to the tires, is designed for one purpose: to keep these giants moving, no matter what the landscape or the weather throws at them. By the late 1970s, Soviet engineers faced a new challenge: how to make the missile itself mobile, not just its components. The answer arrived at the Kama River plant, where CAM-AZ began producing multi-axle chassis designed specifically for the Strategic Rocket Forces Road Mobile Intercontinental Ballistic Missile Program. These were not ordinary trucks. The CAM-AZ 8x8 and 12x12 platforms, built with reinforced frames and independent air suspension, could carry the RS-24 Yars, an intercontinental missile weighing over 20 tons, across frozen rivers, marshes, and dirt tracks deep in Siberia. Production records show that by 1990, nearly 1,500 CAM-AZ missile carrier chassis had been delivered, most assigned to the 31st and 33rd Missile Divisions. Each vehicle featured a centralized tire pressure system, automatic hydraulic leveling, and a split-torque gearbox capable of delivering power evenly to every axle. This meant a single driver could adjust tire pressure for swamp or snow, keep the missile container perfectly level on a forest road, and move a nuclear deterrent hundreds of kilometers in a single redeployment cycle. A former RVSN logistics officer described the shift. "We no longer just delivered missiles to the field. The field became the launch site. Mobility was now the shield." These trucks erased the old line between logistics and defense, turning the chassis itself into a weapon of uncertainty. After 1979, mobility was no longer support, it was deterrence, measured in axles and kilometers, not just warheads. The MAZ 7907 stood as the boldest experiment of its era. Designed in the early 1980s, it had 12 axles and 24 wheels, and it used a Kuznetsov NK-12M gas turbine to drive electric motors at each wheel. Engineers set their sights high: a 150-ton payload and the ability to cross ground where even railways failed. A design memo declared, "The chassis must not fear weight or snow. It must carry the future." Trials in the Urals revealed both promise and flaw. The MAZ 7907's balloon tires and computer-controlled inflation gave it a ground pressure of just 0.45 kilograms per square centimeter. But the turbine devoured 2 liters of fuel per kilometer, and maintenance was relentless. Only 2 prototypes were built before the project ended in 1988, as Soviet leaders shifted to diesel platforms for practicality. Yet the MAZ-79-7's technology did not vanish. Its suspension and tire innovations shaped vehicles used at Chernobyl, where engineers needed to move shielding and gear across radioactive swamps. In the Arctic and along the Baikal-Amur mainline, its design helped relief convoys push through floods and permafrost. As one engineer put it after Chernobyl, "We borrowed from the military because nothing else would survive." By the late 1970s, the contest between Soviet mobility and Western surveillance shifted to orbit. American Corona satellites, operational since 1960, could already spot convoys of MAZ-537s and Cray AS-255s moving across open ground. With the arrival of the KH-9 Hexagon in the mid-1970s, analysts identified individual missile canisters and even tire patterns from 200 kilometers above. Soviet engineers watched as each leap in satellite resolution shrank the room for concealment. Mobility, once a shield, became a liability as NATO doctrine moved from fixed silos to tracking mobile launchers, counting them in satellite images and mapping their routes. The 1987 Intermediate Range Nuclear Forces Treaty marked a turning point. All ground-launched missiles between 500 and 5,500 kilometers, including the 9K7-14 Oka, were eliminated. Soviet crews drove Oka launchers built on those same Imaz and Kraz chassis to inspection sites, where American and Soviet teams counted, photographed, and certified their destruction. As one arms control analyst put it, "The trucks that once hit our missiles became the evidence of their elimination." The era of unchecked road giants ended. Engineering could not outpace the new reality. In the age of eyes in space, mobility alone no longer guaranteed survival. Today, Russia's newest missile carriers still cross vast unpaved terrain, because in an age of satellite eyes and precision strikes, mobility is survival. The Cold War's contradiction remains. Deterrence depends not just on weapons, but on keeping them hidden, moving, and unpredictable. That calculation endures. Share your perspective below.